Good morning, good afternoon, good evening, wherever you're hailing from. Welcome. Thank you for joining us on OpenShift.tv. We are very happy to have you here. I am joined today by my fellow Red Hatter and also a product manager here at Red Hat, Rob Zumsky, the illustrious Rob Zumsky.
Hello, everyone. Happy to be here.
How you doing today, Rob?
Not too bad, just getting my Friday started with a little streaming action. So
that's the best way to start it, in my opinion, man. Let's go. Let's get it. Like we're talking about running a kubelet without a control plane today. Like that sounds nuts to me.
Yeah.
Like, let's start. Let's go, man.
Let's do it. So I want to tell y'all about a little setup I have for running my home shop, which just kind of looks like an edge deployment. So we're going to be talking about edge today. So I've got a few slides, then we're going to go poke around on this machine. I've got some like remote cameras set up on my CNC, so we're going to move that thing around and just see how it works. So it should be pretty fun.
Awesome.
All right, so let me jump into my slides here, and we can go.
Sweet.
All right, so as Chris said, we're going to be talking about a kubelet with no Kubernetes control plane. So who am I? I'm Rob Zumsky. I am now a product manager at Red Hat for OpenShift. I was an early employee at CoreOS, and that's kind of germane to this conversation because I want to start by stepping back and looking at where we started with Kube, which is kind of fun. So I've been playing around with containers in Kubernetes since they existed very, very early on in the Docker space. I think, I have been playing around with this stuff since like 2 versioning schemes of Docker ago, as they keep changing that. And like I said, today we're going to be talking about an edge deployment for my shop, but picture this being applicable to any kind of edge deployment. So let's dig in. So like I said, I want to kind of start from basics here just for like 2 seconds, just because I think it's interesting to, we're going to build it up and then we're going to strip it all away. So where do we start? We started kind of with 3 main technologies. These happen to be the exact things that CoreOS was invested in. So we've got this thing called etcd, which is a database that's used for coordination of distributed systems. And etcd is unique because it's not a high throughput database. It's all about serializability and linearizability. And what that is fancy words for is basically a bunch of machines can agree upon the set value of a thing. And this matters not when you're just tracking like favorite color equals red, but it's like, who is the database master and who is actually like controlling this thing? Everybody needs to agree that it's the same person. And so that database has a bunch of primitives that help you do that. So that's used for coordination. Then, of course, all know about Docker and containers. So we've got containment and, dependency packaging of our application, whatever it is. And, you kind of all know what that is like. So we build on that. And then lastly, we've got systemd for, doing container lifecycle and logs. This is, where we started back in the early days of CoreOS. We were a very early bet for systemd. This is actually before all the Red Hat distros had even gone towards systemd. So we know Kai and Leonard very well, the 2 folks that started that. So we kind of put all of these together. And what's interesting is let's take a look at some of the first work that I did at CoreOS. I wrote a lot of the early documentation. And I just think it's funny to see where we came from on this. So let's jump over to this GitHub source here really quick. And if you'll remember, this is back in the day where this was all new to everybody. And so here's how we introduce you to these concepts. Notice how short these sections are. Service discovery with etcd. Basically, you can curl this endpoint and write like hello world and then get it back. And then it's like, you can also SSH to one of your other machines and get the same message back, and it should be the same value. All right, that's a primer for distributed systems. Next. And then run some containers with Docker. Here's, running an Ubuntu thing that's just going to echo hello world and then exit. And you're like, oh, that's kind of lame. Oh, okay, I can use this interactive and the TTY flag and get a bash shell. All right, that's Docker. Next. Nothing about building containers or anything. And then this is probably everybody's first intro to systemd, which is first go get root. And then let's make this thing a new unit, aka what is even a systemd unit?
What is a unit? Yeah.
And what we're going to do is then run Docker in that. And it's just going to be this like wild true, like infinite loop that just says hello world. And then, all right, go start that thing. All right, that's systemd. Here's your primer for all the technologies you need. That's it.
Let it rip. That's all you need in life. Go.
So you can compare that to like where we are today with Kube and all these high level things. And so that's where we'll dig into next.
Yeah.
So all of these things became things that are run via Kube. So we've got etcd is now under the covers of Kube. So it's
Hmm.
there, but you don't really interact with it. Think how many like things to make Kube work, how many messages you have to write into etcd, and all the nodes, heart beating, and all that stuff all happens. But like, thousands of requests a second if you've got a busy cluster. But it all starts from like something you can curl, which is pretty cool. Well, nowadays at gRPC, see, it's a little different, but um, and so I think the fun thing is where you don't see etcd there is one place in every Kube request where you see etcd, and there's, I forget what it is. There's the monotomically increasing number of the Kube requests. I think it's like the object version or whatever is then directly from etcd. So if you're ever looking at Kube YAML and you see that, that's your only kind of evidence that etcd is there under the covers.
So I already got a question. Can you share the slides and the Git link? The slides, it might be a harder thing, but just share them with me. I'll figure out how to get them out to people.
Sure, absolutely.
The Git link, I think, is funny, but it's really historical, folks. So like, if you think there's something like useful there, it's more funny than anything. I think that like this is how we explain distributed systems way back in the day.
Yeah, that was early 2013, I think.
Yeah.
So, and then if you look at Kube, we've also, Docker is alive and well there, but it's actually now abstracted through an interface called the Container Runtime Interface, the CRI. And that's where if you were running Docker, or we're going to actually poke around with Red Hat's runtime called Cryo. And you don't really know which one you're running or care about it now. It's so low level to Kubernetes, but so important at the same time. And then for lifecycle and logs and all the stuff you have to do to actually run an application, if you're looking at systemd for that, Kube has basically all of the exact same primitives. You need to stream logs back, you need to filter them, all that good stuff, and you also need to start, stop, do some light dependency management is also available. So we're still using the same stuff, which is really cool. It's changed form a lot, which is good for everybody, basically. So let's dig in a little more. So like I said, we're going to be running a kubelet without a control plane. But before we strip that away, I want everyone to just have a baseline understanding of what the control plane is actually doing, because it's going to be important to our conversation about some of the capabilities that we may lose by losing the control plane. So here's a really simple kind of architecture diagram of what this looks like. We're talking about YAML earlier. You pass in workload YAML, and Kubernetes, this API surface is going to parse that and do some stuff. On the left-hand side, we talked about, there's an etcd database here that's, every single thing that's happening is going into this database. And so that's kind of happening constantly. But what's actually parsing our YAML here? You can see I've got the deployment and stateful set and the et cetera, whatever you have in here, is going to be parsed by this thing called the controller manager. And what that does is go spin off all these little loops for desired state, like parsing this deployment needs 2 replicas. Let me go see that, that's desired. What's the actual state? 0 replicas. Okay, I got to start up 2. And it's going to dump out 2 pods that you see in those Ps. And it does that kind of for everything. And if it needs to map storage around, it's going to mark that some of these things need storage and they need new disks and, et cetera, et cetera. And, but those pods just exist. They're not running anywhere. And so there's another, desired state loop there, which is the scheduler that is saying, hey, I need to find a home for these 5 pods. Let me go find some nodes that look like they fit these workloads, and then I'll just map those together. And so the scheduler kind of pairs up each pod and just stores that in the database. It doesn't really care what happens after that. Then the nodes come along and say, oh, hey, you assigned some work to me. Let me go grab those. And so those pods will actually start on that node. And that node will report back a bunch of information about the health of those and how they work. And that's basically how the system works. It's these kind of dedicated control loops, which keep it pretty nice and contained. You can imagine that you know exactly how deployment is parsed, and that code is very focused on that. And the scheduler is just doing scheduling, and the node is just saying, "I run all the things you give me," and that's kind of how it works. And that's all the power of that simple state loop.
We need like a like an updated version of the Kubernetes Illustrated Guide, or like that children's book, right? Like that basically describes this slide, because it has advanced, like the the primitives, yes, are still the same from that book. I mentioned it because I read it to my son the other day during a thunderstorm.
Mm.
So nothing like Kubernetes and a gubernatorial that'll get a kid to like, what are you saying? So the idea here is that, right, like these are the primitives. There's not a lot to it, right? Like Kubernetes at a base level is very complex, but I have been quoted as saying it's just a shitload of YAML and APIs, right?
Yeah.
Like it is literally what's on this diagram here on a very low level.
Yeah. And what's cool is that, I deal a lot with operators and I think they're really cool.
Mhm.
Something that parses a deployment is just like a little loop that is specialized for a deployment. And same for a stateful set and same for a job and a cron job or whatever. But then you can imagine Chris's object,
Yeah.
you just spin off another little one of those loops. You don't need to worry about how it gets scheduled or how these nodes run it or any of this stuff. You just say, for my object, when I parse it, these things turn into pods, these things turn into secrets, like whatever it is. And it all just happens without you having to be an expert in the whole thing. Like you're never writing to etcd. You don't even know that etcd is there nor how it works, which is the beauty of it.
Yeah, exactly. Like etcd is completely abstracted away, and my deepest dive into etcd in my time working with Kubernetes, which has been 2016 now. Yeah, like my deepest dive into etcd was actually the birds of a feather session in Seattle a couple years ago at KubeCon, where I moderated that session, and it was just like, whoa, y'all are running like whole etcd clusters with like millions of records. Like that's crazy, right? Like, and there's people out there that are doing it, and
Yeah.
it's pretty intense. But what you can do with etcd, yes, but under the hood of Kubernetes, it's very, very well used.
Yeah, and it's cool that it's kind of in all distributed systems these days. So like Zookeeper was kind of its predecessor and competitor, and it's just like
Yeah.
super hard to run this heavy Java stack.
God, it was so weird. Yeah.
And so etcd is in all of these like non-kube systems, like all these machine learning and big data things
Yeah,
that
like
need
it's just
coordination. It's very cool.
really, really useful tool.
Yeah. The one thing that we always wanted to do at CoreOS was put up 3 satellites in space that were running an etcd cluster.
Nice.
So obviously never got there, but maybe
No.
etcd is running in space. You never know. Like the
I would
SpaceX
probably say
thing.
it is by now. Yeah.
So you never know.
Yeah.
Anyways, let's move on. So I wanted to dive a little bit deeper into what's happening on the node, because that's what we're going to be dealing with today primarily. And so just wanted to look at the workflow of a node and then kind of what just a sample pod looks like that we're actually going to look at today. So starting with the diagram on the left, this node says, hey, I've got a pod assigned to me. Let's go do something with that. And so once again, it's going to parse that YAML. And it's going to talk to the kubelet. The kubelet is the Kubernetes agent that's on the machine that announces that the node is ready for work, and it has X amount of RAM and X other properties for things to use up in higher level parts of the system. And the kubelet is the arbiter that actually talks to the container runtime, which we talked about through the CRI interface. And so that could be Docker, Cryo, any number of things. And then they both talk to the operating system to pull out different metrics from it. But the container runtime is the one that's actually scaffolding a lot of the C groups and other things that are actually going to contain our code. And then the container runtime is also responsible for talking to the internet to go get your container from whatever registry that it's being hosted on. And then eventually out pops the pod that is actually running your Node.js app or your Python or whatever it is. And then the node is constantly reporting back status. So pod logs. So if you want to, go request the logs, it's going to go talk all the way down to this. Pod status, just saying, this thing is up or not, how many times it's restarted. The node status, is the node healthy? You've seen all the conditions inside of a kube cluster. Then resource usage and other things like that affect the scheduling. And then when the container runtime is actually running all this stuff, what it's actually doing is parsing what you see on the right-hand side. This is a pod YAML that's decently complex. So we've got 2 containers in here. So that pod concept is, typically people are only running one container, but it's actually really powerful in where you can run multiple. So we can talk about that when we dig into the system. We're sharing some certificates between different parts of this stack. Through the volume mounts. So you can see we're pulling this Nginx. We're going to run it as privilege equals true. This is so we can bind to some low-level ports. So we're going to bind to port 443. because we're going to be running some TLS. Got resource limits in here. So the container runtime is actually parsing this and setting up the C groups accordingly for both hard and soft limits. I don't have the both of those set here. Then I'm mounting some volumes in. Now the volume stuff in a pod is really interesting, just like Kubernetes kind of puts layers of indirection in a lot of different places. This is super helpful. So if you were going to move this around between nodes that had maybe different disk setups or something like that, these pod specs don't have to change at all. So you're saying mount maybe read write into this container and then read only in this container, for example. This is helpful for TLS certificates where one thing is generating them, the other one is consuming them. And then you say, and then where that actually ends up on the network attached disk or the local disk or whatever, in this case it's local, is here. And so you only have to change around that lower bit to influence where things are being mounted, and then the config for the application stays the exact same. So that's it at a high level. So that's what we're going to be digging into today, is what if we take away all of this stuff and we're just running this. So what really matters is like, oh, well, you got to lose something, right? You're getting all this benefit and these features, all these control loops exist for a reason. So like, let's talk about like what happens.
Okay.
So now it's worth digging in a little bit more about our goals here, or my goals for this. So you can see my CNC on the right-hand side here. So we're doing a minimal deployment to run all the software that makes my shop tick. So we're going to look at this web interface. That's CNC.js, which is a node-based thing for running the CNC, which is open source, which is awesome. So we're going to approach this like an edge deployment, like I said. So we're going to have a single machine. This is consumer hardware. You can imagine this being in a factory somewhere, or on top of a cell tower, or on a cargo ship, anything like that.
Something, on an airplane, whatever. Yeah.
And so we were going to run the CNC software. I've got a security camera, which is making this video. It's also doing some recording and transcoding. So there's two different pods that do that. We've got our Nginx web server that's actually serving all the traffic. And then we've got an OAuth proxy, which is securing the whole stack against Google Auth. So that's kind of what we're going to talk about here today. But you can imagine, these are useful because anything you're going to deploy out somewhere needs to be remotely debugged, and you might do that through a web interface or streaming logs. You might be running, specialized pieces of hardware like cameras, like industrial equipment, whatever it is. So keep that in mind.
Sensors, all kinds of stuff. Yeah.
And so, like I said, this is an edge deployment. This is kind of how we think about it at Red Hat, along this spectrum. So on the right-hand side is like your core, cloud data center or something like that, very large scale operation. And then going all the way out, you start getting into like points of presence for CDNs or infrastructure that like a Verizon or a Comcast or an AT&T might run in your state, in your city. And then you keep getting all the way over to like individual machines that might be running like smart infrastructure anywhere, things like cell towers, but even like parking meters these days have like, cell connectivity, and they've got little interfaces on them. And then devices, if you're doing, temperature monitoring and all that kind of stuff. So we're going to be kind of on the very left-hand side of this, on that like kind of single server edge thing.
Nice.
So keep that in mind. And then just a bunch of other examples here. There's a bunch of cool stuff. Just think about everything that you have right now that like is running software. All that software needs to be updated. So the airline check-in kiosks to, stuff running on utility poles, to like monitoring the water levels of like a water tank in the middle of nowhere. Like all this stuff has the exact stack that we're talking about. Specialized software needs to be updated. Probably has a web interface, like every cable modem out there, every router, and all this stuff needs to be secure. That's kind of
funny. I like that you picked a robot arm there for like manufacturing. My father-in-law works for a robot manufacturer here in the Detroit area. So I've seen quite a few of those, and they have tons of sensors in them and tons of software running on them. I mean, tons of code.
And like, I mentioned a lot about security, but think about like the efficiency gains of updating that software. It needs to be repeatable so that you can do it on all of them. And like, these factories only shut down for like an hour or two at a time. So you don't want it to go bad. And then the efficiency gains, or whatever, new speed that you're going to get from one of these robots, is super critical. So very cool. So like I said, do you really need this whole control plane to do what we just talked about, to securely update software, to run some of it, and then to have 10,000 of these things running somewhere? And I think the answer is, in some cases, no, you don't. So let's talk about what are you actually missing out on. So what we're going to do is just skip all of that. We're just going to directly write these pod YAMLs, not change anything about that, just directly down onto the node. Now we are going to lose a few things, like, this node is reporting back all kinds of health status and stuff like that. So, where does that stuff go? How do we consume that? So we'll take some examples of that and see what we can do. So that's what we're going to do today. So that is what I call the standalone kubelet. If you've been poking around on a kube system, this is also called static pods. So that's the actual feature in the kubelet that we're going to be using. What's useful about this is can be a fully disconnected use case. We're going to talk about in my setup that it is connected. It doesn't have to be. And so it's fully compatible with a bunch of automatic provisioning technology. And, you can make golden images of things that are running all this software. We're going to talk a little bit about Ignition and Cloud Init and some of the things that we worked on at CoreOS to make it really easy to provision immutable infrastructure. And it's even more powerful with the self-managing OS. So if you've got either Fedora, CoreOS, or Container Linux was what we worked on at CoreOS. If you have thousands of nodes out there, you kind of want them to self-manage themselves. And that's like failover for their applications, but also software updates for the operating system itself. And so
rollbacks if it fails, that kind of stuff. Yeah, exactly. Yeah.
Because think about like your water meter or whatever. Once again, bunch of software running on that. You don't want them coming out to like an entire neighborhood set of water meters when they brick it with like a software update.
And you know what's funny is I'm sure it's happened.
Oh yeah.
Oh.
Yeah, absolutely. And then lastly, the tie-ins to the kube here. So we're still running the kubelet. We're using the container runtime interface like normal. We're also using the container networking interface, which we didn't talk about, like normal as well. So we can go look at what those configs look like. They're obviously very simple because we're not doing a ton of the heavy lifting. So that's what we're going to dig into today. So what does this actually look like in practice? So on the left, you'll see I just catted out the kubelet service and systemd. The unit, and basically all the config, it's just all environment variables, which is just interesting. So environment file is how you actually pass in a whole set of environment variables into a systemd unit. And so on the right-hand side, that's the kubelet config that we passed in. A few interesting things about this. One, did you know that they used to call this thing the minion? That was like a Borg.
I didn't know that. Yeah, that was a Borg thing. Yeah. Instead of workers, it was minions.
Yeah, so that was still in here. I didn't know that was there. And our kubelet address, we're listening locally. We're not doing anything with an API server because we're not talking to a control plane. So that's interesting. We do have the info port open. And then when you get down to the args, it looks fairly standard. And in every kube, you'll see this pod manifest path typically, and that's just a directory on disk. And that's going to be the power of this whole thing. We're just going to place some pods in this directory and they're going to start. And that's the magic of this whole thing, which is kind of awesome. And then we've got some container runtime stuff. So we're going to talk to our cryo socket remotely, local, but Unix socket. And that is our setup. So we talked about pros and cons of this. So something's got to not work. So let's talk about what doesn't work first on the right-hand side here. So anything that stamps out pods, we don't get to use. So remember, we talked about that control plane. It's just stamping out pods for that controller manager. None of that stuff is running. So scaling out deployments, like replicas 5, and then now I need 10, stamp out 5 more. None of that stuff works because we don't have anything to stamp out pods. And also in those environments, you're typically running them on multiple nodes. And so we don't have multiple nodes here either. Any different types of networking that works between nodes. Remember, we don't have multiple nodes. So like services and ingress and network policy and all that stuff. You could argue that maybe network policy would be maybe useful, even local to a node, to keep some pods away from each other. We've got some other facilities for that. And realistically, you need to be trusting what's on this node. And then we don't have that control plane to do any eventing. There's no RBAC. There's even no authentication. This thing is not listening to the internet. There's nothing that needs to be secured. And then all the mapping that we're going to do for volumes is going to be host mounts because we're running directly on the host. This thing isn't going to move to another node. So there's no persistent volumes in PVCs. but we can still use storage, of course.
Yeah.
And then there's none of that cool custom stuff like we were talking about operators and where that would plug into this whole thing. Other custom controllers, admission controllers, all that stuff. Remember, there's no control plane. So
yeah, there's no admission webhooks. There's no nothing. You're not getting anything. Yeah.
But think about it's always, I think, really useful to like, especially if you've been deep in Kube, just like comparing this to like some other thing, like just where we started, where you're just reading and writing to etcd randomly and running Docker commands yourself. What does work? So you can have a pod with multiple containers. That's a super powerful concept that we kind of take for granted now. But even just orchestrating 2 or 3 containers to work together is an accomplishment.
Yeah.
And in that pod YAML, if you remember, we've got the volume mounts. We're setting some security contacts. We've got resource limits. We can do port redirection. We can use node ports. So we can have network traffic, of course. We can stream logs back. We can attach to our containers. We can exec things on them. We can restart them when they fail. So all these really powerful things that even your like standard cable modem needs to do all of that stuff. And obviously they're doing it somehow. Could it be cleaner with this? Probably.
Mm-hmm.
So with that, we do need to make some changes to our workflows versus just using like a standard kube cluster. So let's talk about that. So I remember I said there's no ingress. So I want to get web traffic in here. So we're going to run an Nginx container on a node port running on 443. And that's just going to work exactly like an ingress controller. All my clusters anyways, I run an Nginx controller, whether my platform provides one or not. So this is, very easy for me. I kind of understand how this works. So not that bad. We're also going to be, issuing some certs and things that like the ingress would do for you anyways. And then for volumes, like I said, we're going to be persisting directly to the host storage instead of to a PV. And that's because we don't need that indirection of moving storage around, remapping EBS volumes or anything like that. Don't need it. And then the big one is probably going to be the CLI tool. So we're going to remember kubectl is talking to the control plane for the most part, and then sometimes we'll get redirected down on the node to stream logs back and things like that. But that needs a control plane to organize that. Remember, there's no API that's listening on this kubelet right now. So it's kind of hard to use kubectl. So what we're going to use is cryctl, which is CRI. Remember our container runtime interface. The cryo is Red Hat's container runtime, and this is the control program for that. And so it's got all the same kube primitives because it supports pods. It's made to be run in Kubernetes. So everything kind of works the exact same for the flags that we need. So logs-f, is going to follow your logs for you, just like kubectl logs-f would. So that's going to be the main way that we're going to interact with our containers.
Sweet.
Just what this looks like in detail, we can also poke around on the box here. This is the best part, I think. Deployment. All you got to do is get this thing on disk. So SCP, great deployment tool, underrated.
Underrated deployment tool of the year.
I mean, you can imagine even deploying something to like 1,000 machines by just doing like a while loop in a bash script or like a fabric script if you've ever used that to just place these things on disk. That's all you have to do. And then once we kind of explore the easy way, I'll talk about some hypothetical ways to do this in a much more scalable manner. Then going and listing our workloads, we're just going to jump on the box and run cryctl ps, just like you would with Docker. It's kind of a blend of both if you are familiar with that. And you'll just see that we've got our few containers here. This is actually 3 different pods, but 4 containers. So you see 4 containers here because 2 of them are in one pod. Then, you can do all the usual stuff. We're going to stream some logs back here. I mentioned that we have this OAuth proxy. And so here it's authenticating me and then serving up the web traffic. And so it feels, if you've ever run Docker manually or any of those tools kind of outside of Kube, this is what it feels like. It's kind of back to basics, if you will.
And this is kind of how we troubleshoot pods internally in OpenShift, right? Like,
right. Yeah. You always have
we jump down on the cry logs.
Exactly. You have to jump down onto the box at some point. So we're just doing that most of the time instead. And then, once again, I just want to lay out that, like, if you were going to do like a deployment of a modem, cable modems or whatever, you're going to have to invent a way, like an API of interacting with those things to do remote management. Yeah. And here we're reusing the Kubernetes pod. That is the API. So you're not like reinventing anything. You can still take like pod examples off the internet that work. Anything that mutates pods or generates pods, any tooling, CLI, dev tools, like all that stuff may need a little adaptation, but it actually just, you're dealing with the same core object. So you've got all the cool stuff that we just talked about, the restart policies and resource limits, and liveness and readiness probes is like something that, container runtimes don't really do directly, but you get from a kubelet. So you can say, hit this health Z endpoint and things like that, which are really helpful. That's like kind of a step up, and all the volume mountings and all that stuff. So it's a really great API. It's very elegant. And remember, it's just YAML. So you can send it around with some curl or some SCP, which is really awesome.
Some rsync or some
exactly.
whatever.
Whatever you want.
Yeah.
So very, very cool. And that's like the kind of the core concept here is if you're going to build out an edge deployment, try to not reinvent stuff. You don't need to reinvent your own agent, your own, format for running the containers and all that stuff. This is your config file. Just makes a lot of sense.
Right. Exactly.
So let's maybe jump onto the node and then we'll come back to kind of talking about scaling this. So like I mentioned, we are on my Fedora box here. So, whoops. So this is Fedora 31. I'd like to adapt this to run Fedora CoreOS, but we're not there yet. So
that's understandable.
What I've done is just, I installed the kubelet. So we can go look at that. We already, kind of looked at that before. This is its really minimal config. And then if I go to, let me move this Zoom thing out of the way. If I go to Etsy Kubernetes manifest, remember that was the static directory that we're going to be looking at. This is where all of our files are. So you can see we've got our 3 pods here. We've got the kubelet log. So the CNC is the software that we're going to look at in a second. Nginx is securing the whole thing. And then we've got this transcoding service, which is mapping some of our camera output.
Nice.
Let's just jump on over to the CNC really quick. So this is the software that we are running it's a little Node.js app that talks to our CNC over what is a USB connection. So it's a TTY device on the box itself. We've got this webcam streaming here. And I actually did go turn this on so we can go play with it. So
nice.
I'm just going to go move it around a little bit and you can see it actually moving. You can see some of my clamps there in the corner. But that's small, so let's open it up here really quick just so you can see it.
Get the full tour here. Wow. Fancy. Yeah. Oh, nice.
So we should get a stream here. So this is the more high quality version of this. So you can see I've got some clamps. I don't have a workpiece down right now, but this camera is mounted on this arm, so it does move back and forth. So
very cool.
The system coordinates are a little different than when I'm used to it at this angle. So you can just see things moving around. But imagine you upload a program here, and this thing is just cutting.
Right.
And sometimes it takes several hours, and so theoretically you should stay there and watch it the whole time.
Yeah, I mean, yeah, you're supposed to. Yeah, in theory.
So I like to look over, and if there's any flames, shooting, gotta run over there.
There's bright flashes of light.
Yeah,
it might peek over.
Yeah. And so what's cool about this, if you look at it, this is running at home.robsumsky.com over TLS. This is going through that OAuth proxy. I already, was logged in. So it's just kind of transparent, which is really nice. Just like if you have corporate SSO that does that. And so these cameras are actually local. Maybe we'll put them on the internet one day. I want to solve all these problems because if I did want to have a bunch of security cameras and put them on the internet, now I've figured out how to serve web traffic and get this Nginx all set up and all that.
Mm-hmm.
So it's all iterations.
You and I can work together on this, like I can help you with this. I've learned a lot about RTMP and everything else. Like
exactly. Yeah.
You could totally use like a obs.ninja type thing and totally have this broadcasted out on the internet. Like no problem.
And so
people in chat are saying this is some Tony Stark level stuff here. So
I don't know about that. But speaking of the real-time streaming protocol, so I have these 2 pods, one of which this time lapser is not running right now, but it's just constantly looking at the real-time stream and then transcoding it. So here you can see it's configured to make 60-minute segments. And then it dumps them into this recording directory. I haven't gotten it. It keeps filling this directory up. The rotation logic I have doesn't work. So there's called Tiny NVR, which is I forked some other guy's thing. But that's really cool. And so it creates time lapses automatically, and it's just doing FFmpeg under the hood.
Nice.
And then here, this is the real-time stream to MJPEG. That's actually what you see in this corner down here. This thing, because the guy didn't want to deal with any of the security around actually parsing feeds. He just says MJPEG is like a movie JPEG, and it's just outputting frames constantly instead of like you load it and the JPEG is done loading. The video just never ends. And so I had to find a transcoder to do that. And so, that's just taking direct FFmpeg stuff. Some guy wrote this, so I just tweaked it a little bit. But you can see here, we've got resource limits on all this stuff. So if they are running amok,
I love the fact that, like, one of the things I always preach to people is always put resource limits on your pods. And even for this use case, you have resource limits.
Yeah. Well, it's just nice. I'm not inventing how that works. So you can see here, this C9 container is the one that's actually doing the transcoding. So it's sitting at 8% CPU, kind of constantly doing its thing. Not a ton of RAM usage. So this box has got like 16 gigs of RAM, which is being vastly underutilized. So yeah, that's kind of the way the system works. Here is my CNC pod is nothing that crazy. You can see here that all this stuff is listening locally only. So the only punched hole into this box is my 80 and 443 for the ingress itself. So this stuff is listening. It's this remote access is that they just don't want it listening on all interfaces.
Right.
And this is actually mounting in through a Kube volume mount, the USB device that is actually the CNC. Then I've got my Nginx pod, which has two containers in it. One that's actually running Nginx, and one that's running Let's Encrypt, and the OAuth2 proxy. So I want to thank the folks at drone.io. I stole their Nginx that secures their remote CI builders that does Let's Encrypt and stuff like that. And so
nice.
they
I need to steal this then.
Yeah, they have that all set up already. I think I had to fork it because I wanted to change a little bit of their Nginx config, but it basically just works. And then I've got my proxy here with all the OAuth settings in it that is just running, and that's kind of the whole setup. And so what's really cool about this is, like I said, there's files on disk. And so when I update stuff, I've got a little directory where I store them and then just SCP them over. You can also like just edit them with Vim or whatever on the box itself. And you can just, get all the same stuff that you're basically used to with Kube, but just in with this cryctl, or you can also grab the journals of these from journalctl as well. So it just feels like a little lower level Linux, kind of back where we were. One thing you can see that these have all rebooted a bunch. I need to track down exactly what's going on there, but they start back up, so I don't really care that much.
You've got all this on a Git repo somewhere, right?
I don't have all these pods. I do have, so this config is a gist right now.
Okay.
How to set up this box. So this is actually a good segue back into what I want to do with this one day, which is I want to scale this out and make it more commonplace to do. And so instead of like configuring this Fedora box kind of manually like I have, and the gist has some of those examples, what I want to do is use Ignition, which is kind of this machine configuration language that CoreOS invented, and it's designed for like immutable infrastructure. And the cool thing about that is it runs during the init RC or RD of the Linux box, which is like the RAM disk that actually like starts the kernel, and so it runs before systemd starts, before PID1 starts. So you can configure a bunch of stuff about the box that is typically hard to do. So you can RAID disks and do bonded NICs and things like that before any of that stuff actually comes up and is being utilized. So it's not even like a reconfiguration, it's a configuration.
Yeah.
And so you can imagine, so if you've seen Kelsey Hightower's Kubernetes the hard way, he's got a bunch of other things, and one of them is running static pods with a standalone kubelet that uses container Linux, which has now been end of life, and so it needs to be updated. And I'd like to hopefully contribute back to that and use Ignition, which it was already using with Fedora CoreOS instead.
Nice.
So you can imagine what that would be is just go boot this machine, feed it this config, either via a kernel parameter, or if you're on the cloud, user data, and it would just come up, and all you have to do is SCP a file into that directory, and it would just work. It could all just be configured for you. And then you can imagine how easy it would be then to stamp out thousands and thousands of these things. And so that's kind of what I'm showing here is, the process on the left-hand side. You could make some golden images and just like produce an AMI of this stuff, which would work too for small scale. But really what you would do is you would have this ignition file that is checked into like a cloud storage bucket somewhere. And you would have thousands and thousands of sensors that would just say, go pull down this file and configure themselves. And then they would also check a different storage bucket, for pod YAMLs that they're supposed to run.
Right.
And that could just be a simple systemd timer saying every hour go curl down these files, and that's like your deployment mechanism.
Wow,
there's nothing to scale here. Obviously, you need to make sure that your pods start correctly, but it would be super immutable, super easy to test. And then you do have this like kind of remote management functionality to be updating things. And I think these types of systems work for really nice edge use cases, and it's just not that complicated. Securing these things, it's kind of a one-way only directional interface. Obviously, you could be validating signatures and all that good stuff too. So that's where I'd like to get to with this deployment, and then make it really, really easy for other folks to run this.
So, Christian Hernandez asked a very valid question in chat, and I feel like I kind of know the answer. But if you want, why not Podman?
So I think that is also another good use case. So Podman is a Docker-like client for, it's kind of a mix between Docker, which is like single container, and then so Podman understands pods, hence the name. So it functions, if you're used to Docker Compose, a little bit more like that. I think that works. The thing that I think you get from running the kubelet is you get that pod API. That Kubernetes API is like the power of it. So all the things that we talked about that are in here, you're doing this, but if like these edge machines are working with an actual Kubernetes control plane or cluster, that's running at that central data center, you can start moving workloads between. Now you might need to adapt them, like I said, for the no volume stuff like that, but you're like the tools that you use to debug, you kind of understand exactly how this works when you're using that same thing both in your data center and your edge nodes. It's kind of the way I think about it, but I don't think Podman is a bad thing at all. It also would fulfill the same thing.
Right, but I think you would need a lot more under the hood to actually run it, maybe.
Yeah, because you just need all of this type of stuff, and Podman does have some of these concepts, like the multiple containers and things like that. The things that Kube I think just nailed is all the volume mapping and port mappings and all that stuff. And everyone is like kind of stealing from what they did anyways, and that's great. That's how open source works.
Yep.
So a lot of these concepts are leaking into all these other tools anyways.
Exactly.
Yeah. So that great question, Podman. If you haven't checked it out, go check that out as well. And then last, I want to say, check this out. So here's the gist. So under my colleague Daniel Messer's GitHub, I thought I'd forked this and made some changes, but I cannot for the life of me find it. Hence I just want to move to the ignition thing anyways. Kelsey Hightower's standalone kubelet tutorial, which I crib a lot of the concepts from. Kelsey worked at CoreOS for a little bit, and we overlapped there, and so we kind of hacked on some of this stuff together. So I think it's a really cool concept, and hopefully, this hasn't been updated in several years now, and so I'd love to see it get more traction as folks kind of get back to basics, and that's what I want to talk about today. Oh, and last thing. Please tweet at me if you try this out or if you have any questions. Like I said, I want to make this a thing. I want to help people do this. So if you have any questions or you do have success doing this, please tweet at me. I'd love to help you out.
Yeah, he is at Rob Zumsky. I will drop his Twitter handle link thingy in as soon as I find it, because I just had it up here just a second ago, I swear. So what's your CNC machine doing right now? I mean, is it just chilling?
So it's chilling right now. But so I don't typically run it during work. I mean, just because
like that's safety.
Yeah, you're right. Well, so the crazy thing about a CNC is like that thing is like it's a computer controlled router. So I refer to it as like more dangerous 3D printing. So that thing spins at like 10,000 RPM. You can shatter the bit and like shatter, stuff all over your shed, get in your eyes, for example, or
ouch.
And if you let's go back to the camera. Oh, I quit. what's really a big part of CNCing is work holding, like clamping down your workpiece. And so you saw some of my clamps on the work surface there, not holding anything, but hey, come on.
You can do it. You can do it, JPEG.
Well, this is actually coming off the camera directly, so it should.
Wow.
Be,
okay.
Is it still open? Is that why?
Oh yeah, maybe have it open another window tab somewhere.
I don't know where it is. Anyways, you can kind of see it down here.
Yeah.
These clamps, there's 4 of them. So like as this thing is spinning really, there we go, really, really fast, you need to hold it down because like the torque of the actual cuts can like fling this thing across the room too. And so if you're cutting like a piece of aluminum or something, that is not good. And so I've been just playing around with a whole bunch of stuff. You can see here this little thing back over here.
Yeah.
This is Sutro Tower in San Francisco. CNC. It's
Cool.
like a
That's
tote rack.
awesome, man.
Yeah, so I make some stuff like that. I'm also I'm into clocks right now. I want to like make some cool clocks. So like when I'm streaming and like talking to people all day on VC, imagine a clock back here that is like dynamic and is moving and doing cool stuff.
That would be
One of the things
amazing.
I've been prototyping is like this, like a maze clock. So imagine this filling up with like little dots or something every hour, and then it goes back down and fills back up again. So every meeting is an hour.
That's cool. Yeah, that would be awesome.
So I've been playing around with some of that kind of stuff. But yeah, you can cut all kinds of things. So little trinkets and signage I made, like just like some house numbers and all that kind of stuff. But people have whole businesses, like, imagine all that stuff you could put on Etsy on one of these things.
Oh yeah, no, like CNC people are needed left and right here in the Detroit metro area. So like I see signs on like street corners, like you see like for like painters, right? Like in normal cities, you see like CNC machinists wanted here in Detroit, right? Like it's pretty wild. So yeah, like the fact you have one like strapped up in your shop with a camera and everything, that's pretty dope to me. So that's awesome. Thank you for coming on and sharing this with us. This is awesome, man.
Yeah.
Wow.
Marries
this is cool.
2 of my hobbies together. It's kind of rare that you get to do that. So,
right. Exactly. Yeah, this is cool. So thank you so much for joining us, Rob. Yeah, look forward to having you back on in the future sometime. Later today, folks, stay tuned at noon Eastern, 1600 UTC. We've got OpenShift Commons briefing, Pragmatist Guide to Wordly Mapping with Ben Morsorer from Hired Thought. So that should be super interesting if you are into the wordly mapping kind of stuff, or if you're even curious about it, just tune in and check it out, right? Like I'm going to learn something new for sure. I guarantee it just by being there. So yeah, looking forward to see you all then. Rob, thank you again so much.
Absolutely.
Please share your slides and stuff with me, and I'll get those out to everybody. We're going to find a place for slides, and I will link to it in the README on our GitHub repo, folks. So just stay tuned for that. Don't worry. It's been a work in progress all week. I'm tired of dealing with it. I'm just going to start dumping stuff somewhere. So, yeah, just yeah. Anyways, all right. Thank you all. Stay tuned. OpenShift.tv. Follow me on Twitter at Chris Short, and follow Rob Zumsky on Twitter at Rob Zumsky. And talk to you all soon.
Have a good one. Thanks.